In today's lesson, we are going to be looking at adding and subtracting rational expressions. So we've already looked at multiplying and dividing rational expressions. We've had to find restrictions. We're going to be doing the same thing, but we're going to be doing it as we add and subtract fractions. So there's going to be that additional step of having to find a common denominator, right? Because when we're dealing with fractions now, or the rational expressions, we have to have common denominators when we add or subtract. When we multiplied and divided, we didn't have to worry about that. We could just kind of look for restrictions as we go through and simplify. This is going to be a little bit different. So just a little bit of review to kind of get us kind of up to speed with what we've kind of done so far. We want to simplify the following or evaluate 1 over 6 plus 1 over 5. Right? So here is two fractions. We're adding them, so we need to have a common denominator. If we can't find a common denominator, we can't think of what the common denominator is, easy solution is to multiply both fractions by the denominator of the opposite. So that's why we're multiplying the first fraction by 5, the second fraction by 6. To keep it equivalent, we have to multiply both parts, so both the numerator and the denominator. So 1 over 6 becomes 5 over 30 plus 6 over 5, or sorry, 1/5 becomes 6 over 30. Now that I have a common denominator, I can just add my numerators. So I get 11 over 30. So 1/6 plus 1/5 is 11/30. B, simplify and state the restrictions. This is similar to when we multiplied and divided our rational expressions. We have an irrational expression here. We want to simplify it. One thing we have to do first, however, is we have to start looking for restrictions. And we want to do that at the very beginning. So if I look at it right now, is there anything that is apparent in terms of what the restrictions are? In this case, no, there's not. So I can't really do anything right now. However, what I can do is I can now start to factor. So looking right now, there are no restrictions that are apparent. I don't have any factors or single terms or single variables, right? I recognize a trinomial, so I have to, or I should recognize that I have to factor that. I have two terms here, x squared minus 1 and x squared minus 4. Those don't look like trinomials. However, we should recognize that they are difference of squares. So if I'm going to go through and factor this, the x squared minus 1 becomes x plus 1 times x minus 1, all divided by, we get x plus 2 times x minus 2, and then we're multiplying all of this by, now if I'm looking here to simplify, these are perfect, or not perfect squared trinomials. They are simple trinomials. So here I would be using product and sum. So two numbers, first one, two numbers that multiply to -4 but add to 3. And for the second one, two numbers that multiply to 4 and add to 5. Here we're going to get our two numbers are, we have negative or positive 4 and -1. And here we have positive 4 and positive 1. Oops. So simple trinomials, so again, does help to make sure we know our factoring. So then the first, or the numerator of the second rational expression becomes x plus 4, x minus 1. And then the denominator becomes x plus 4 times x plus 1. Those are my two kind of factored rational expressions. Now that I have it in factors, now I can recognize or start to see some restrictions. Right? So if I'm looking at the denominators, x cannot equal, I see -2, +2, -4, and -1. So I'm looking at only the denominators for the restrictions, because again, the denominator can't equal 0. Now I can go through and I can start to cancel things out, right? I could multiply everything together and just write this all out in a long list. Oops. For example, such as x plus 1, x minus 1, x plus 4, x minus 1, all divided by x plus 2, x minus 2 times x plus 4 times x plus 1. I could do it something like that and then look to cancel out, or because I know when I'm multiplying, I'm just kind of multiplying the numerators and the denominators, I can go through and simplify, canceling out terms on the bottom and terms on the top. So I have an x plus 4 and an x plus 4 I can cancel out. I have an x plus 1 and an x plus 1 I can cancel out. This leaves me with x minus 1 squared on top, divided by x minus 2, or x plus 2, x minus 2. So that is my simplified expression. And I now have my restrictions. X cannot equal -2, 2, -4, -1. So that's my simplified expression and the restrictions. So remember, the restrictions you have to look for as you go. And nothing new has changed in the denominator since we found our first restriction. So this is a simplified form with the restrictions. And lastly, for C, we have, again, a rational expression, adding another rational expression. Right? We want to simplify and state any restrictions. This one's going to be a little bit easier. If I'm looking for a common denominator, though, right, I have two components here that I have to look at, the numbers and the letters, or the variables. So my numbers, 3 and 6, I can change the numbers on this one to easily get to 6 by multiplying both parts by 2. Because the 2 times the 3 will give me 6. However, I do need the x, so I do need to multiply both parts by 2x. So that would make the first fraction 4x squared over 6xy. So I have a common denominator of the 6 and the x. However, my second fraction would need a denominator of y. So I need to multiply both parts by y. Adding y squared divided by 6xy. Technically, before I did that, what I should have done is I should have looked for restrictions, and of which there are 2. So initially, x cannot equal 0 and y cannot equal 0. So I should have looked for the restrictions at the beginning. However, it doesn't really change anything when we go through because nothing new really comes up. Now that I have a common denominator, I can add my numerators. So I have 4x squared plus y squared. I can't simplify that. They're not like terms, so I'm going to leave them as is. And I divide it by 6xy. My denominator stays the same. I don't add my denominators. It stays at 6xy. Numerators I can't add because they're not like terms. So that's as simplified as it gets. And I can state the restrictions of x cannot equal 0 and y cannot equal 0. So what we're doing in example C is what we're going to be looking at in more complex terms, right? But it's the idea of getting a common denominator and, again, still looking for restrictions as we go through. So first we're going to look at examples where we have a monomial denominator. So we don't really have to work, it's the simpler version, similar to what we just kind of looked at. There's only one term in the bottom that we have to worry about. So 1 over 5x plus 1 over 2x. This one is a little bit simpler. They both have an x. It's the numbers that are different. Right? So I have to make sure or ensure that the numbers in my denominator are the same. So in this case, the lowest common denominator would have to be, well, one, it has to have an x, which they both do, so that's good. The common denominator, but for the numbers, the lowest common factor of 5 and 2 would be 10. So 10 is the smallest number that both 5 and 2 go into. So how do I get those denominators there? Well, I have to multiply this fraction, or the second fraction, by 5, and the first fraction by 2. Again, everything that you multiply to the top or the bottom, you have to do the top. So this would become 2 over 10x plus 5 over 10x. Equivalent fractions haven't really changed the denominators in any sense other than the numbers, so it's okay if I look at my restrictions now. X can't equal 0. The only restriction that we have right now. I'm going to go through, I'm going to add, so 2 over 10x plus 5 over 10x, common denominators, I just add my numerators, so I get 10 over 10x, oh, not 10, multiplying, 7 over 10x, so 7 over 10x is my simplified expression, and the restrictions are that x cannot equal 0. For B, a little bit more complicated now, because we still have a monomial in the bottom, but it's more complex than just a coefficient and a variable. Now we have multiple variables and coefficients as well. But again, right, we want to look to see, we have some steps. We want to look to see if we can factor. We want to get a common denominator. We want to rewrite the expression with a common denominator, add or subtract the numerator, then simplify. Right? And again, the main thing, right, is we want to state restrictions throughout the process. Right? The above steps are just how to add fractions, essentially. We do want to look to factor. In some cases, which will be more apparent in the next couple examples, but the main thing is stating the restrictions as we go through. So I have two expressions. I'm subtracting. I'm going to look to see if there's any restrictions. Well, right now the restrictions for A cannot equal 0, and B cannot equal 0. Those are my two restrictions that I can see right off the bat. I'm going to look for a lowest common denominator because I need to add, or I need to subtract these two rational expressions. So the lowest common denominator in this case is going to be, well, I have 2, so 2 is going to be common. I see that one has a b, well, b squared. I can't reduce that, so b have to have a b squared, and it looks like both have to have a's. Right, so the lowest common denominator is going to be 2ab squared. So let's see what I have to multiply each fraction by, or each rational expression by, to get that common denominator. Well, for the first one, I don't have to multiply it by anything because that is my lowest common denominator, or that is my denominator already. For the second fraction, I do have to multiply this by an AB. Because when I multiply both sides by, and again, using the brackets to signal that I have to multiply both parts, the numerator and the denominator. So I'm going to multiply that through. The first fraction is going to stay the same. The second fraction is going to become AB times B plus 2 divided by 2ab squared. I have a common denominator. I can look for my restrictions. Nothing new has come up. So I'm going to go through, I'm going to add. Before I can add, though, I want to simplify the top of the second fraction. So AB times B is AB squared plus 2ab. They're all divided by still 2ab squared. Keep in mind, because we're adding and subtracting, we can't really cancel anything out on the bottom and on the top, not like we could when we were multiplying. So we can go through and we can add now. So I have 8, or the denominator is going to stay the same, sorry, 2ab squared. For the numerator, I have ab squared plus 2 minus ab squared plus 2ab. Well, I can cancel out the ab squareds because if I have a positive and a negative, they cancel out. So these two end up canceling out. I'm left with 2 plus 2ab. Again, no new restrictions still in the denominator. Looking to see if I can cancel anything out. Well, I can factor actually the top. I can remove a common factor of 2, which makes it 1 plus ab divided by 2ab squared. And this I can actually cancel out the factor of 2 because now I'm multiplying, essentially. So I can cancel out those two coefficients. I get 1 plus AB divided by AB squared. No new restrictions have popped up. So this is my simplified form. So it doesn't look like 1, it looks like the word tab instead of plus AB. And then my restrictions, A cannot equal 0 and B cannot equal 0. So the restrictions didn't really change. So this was more about adding and subtracting or working through the simplifying of that. So 1 plus AB divided by AB squared. And the restrictions are A cannot equal 0 and B cannot equal 0. Next, we're going to look at adding and subtracting rational expressions with polynomial denominators. So this is going to be a little bit more challenging because we have greater or more complex denominators. So again, we want to factor where possible, factor the denominators where possible to help us get a common factor. We want to expand the numerators. In this case, because we are going to have to multiply or add or subtract, and we can't really cancel things out when we're adding or subtracting. After we expand, we want to then add or subtract the fractions, simplify where possible, and again, state the restrictions throughout the process. So if I look at the first two, x plus 5 divided by x minus 3 plus x minus 7 divided by x plus 2, I want to look for a common denominator. Now in this case, it's going to be difficult because, well, what's common between x minus 3 and x plus 2? I have two separate terms. Again, we can treat them as full terms or one term itself, or we can treat it as a factor, so to speak. So I'm going to multiply each fraction by the denominator of the opposite. So I'm going to multiply the third fraction by x minus 3 and the first fraction by x plus 2. So in this case, my lowest common denominator would be x minus 3 times x plus 2. So I'm going to multiply both parts. So I'm going to have x plus 2 times x plus 5 divided by x plus 2 times x minus 3. And you're like, well, why can't I cancel that out? You could, but you'd end up right back where you started. And when we look, because we're adding our fractions, we can't cancel out across the fractions because we're adding. We could cancel out within, but again, we would end up right back where we started, which isn't going to help us when we want to add. So now we have common denominators. We can go through and add, but we do need to state restrictions as we go through. So right now my restrictions are x can't equal -2 or +3, because I have my two factors on the bottom. Now I'm going to add, or I'm going to expand, sorry. So I want to expand so that I can add to make it easier, because if I was to add this, I don't know what each of these equals. It'd just be 2. It'd be x plus 2 times x plus 5 plus x minus 7 times x minus 3. So it'd be the exact same thing, which doesn't help us. I'm going to expand. So I get x squared plus 7x plus 10. So I'm just simplifying that process, but it's essentially foiling the top. And then that's still divided by x plus 2 times x minus 3. I'm going to leave the bottom still separated or still factored because I am going to end up having to factor the top anyways. Then x minus 7 times x minus 3, I get x squared minus 10x plus 21. So again, foiling. We have x plus 2 times x minus 3. So now when I go through and I add this, when I add my numerators, x squared plus x squared is 2x squared, plus 7x minus 10x is minus 3x, plus 31, divided by, and then x plus 2 times x minus 3. Nothing new has changed in the denominator, so my restrictions stay the same. So my goal now would be, okay, can I factor or can I simplify the numerator? Right, so do I have factors that multiply to 62 but add to -3? If we think about that, we could think about what the possible factors are. But if we would find that there are not any, we can't simplify it into nice factors. We could, if we wanted to, use the quadratic formula to find the x-intercepts for that top part, which would technically be our factors, but it wouldn't work out to anything nice. So we don't want to factor it, or we can't factor it. Because it's technically not a quadratic, so we're not simplifying in that form. So this is just going to stay as 2x squared minus 3x plus 31 divided by x plus 2 times x minus 3. And then the restrictions are going to be x cannot equal -2 or 3. So again, the main thing is, again, looking for the restrictions throughout the process, recognizing that we can't cancel things out like we used to when we were adding or subtract, or when we were multiplying or dividing, because we're adding or subtracting now. B, the next example, x plus 9 divided by x squared plus 2x minus 48 minus x minus 9 or divided by x squared minus x minus 30. So what we want to do first here is we need to factor the denominators, right? We need to get a common denominator. So in order to do that, we would need to factor. That will make it easier to figure out, okay, what do I multiply by? The numerators are going to stay the same for right now. For the factors on the bottom, I'm looking for two numbers that multiply to -48 but add to 2. I'm looking for two numbers that multiply to 30 but add to -1. So in this case, my two values are, we have 8 and -6, and we have -6 and 5. So I can rewrite the denominators as x plus 8 times x minus 6. And then for my second one, I have x minus 6 times x plus 5. So looking at my common denominator, or my denominators, the common denominator, they do have two similar parts, the x minus 6 and the x minus 6, so that's good. So I know my common denominator is going to be x minus 6 as one factor. I also have an additional parts of an x plus 8 and an x plus 5. Right, so this is just a complex version of multiply by the opposite denominator. In this case, I only need to multiply the one side by the x plus 8 and the other side by the x plus 5 because they already share one part. So what's going to happen now is I'm going to multiply this side by x plus 8, and multiply the first one by x plus 5 and x plus 5, and that will get me a common denominator. I'll have x plus 5 times x plus 9 minus x minus 9 times x plus 8 divided by that long string of three terms, or three factors, x plus 5, x plus 8, x minus 6. And the other one is x plus 5, x plus 8, x minus 6. So the exact same denominator. I want to expand the top before I can add. So x plus 5 times x plus 9 becomes x squared plus 14x plus 40, or sorry, 45. Divided by x plus 5, x plus 8, x minus 6. That's going to be subtracted from, we'll have x squared minus 1x minus 72. So again, I'm just foiling the numerators. The denominator is going to stay the same. x plus 5, x plus 8, x minus 6. My denominators haven't really changed, but what I could do, or what I should have been doing, sorry, is I should have been looking for the restrictions. So right now, x cannot equal -5, -8, or +6. That hasn't changed throughout. That would have been the same even at the beginning. So that's okay that we didn't quite do that right away. When I simplify now, I'm going to add and subtract my numerators, or in this case, or collect like terms, so to speak. So x squared minus x squared, that cancels out. So those two are gone. 14x minus -1x is 15x. And 45 minus -72 is +117. The denominator stays the same. X plus 5 times x plus 8 times x minus 6. I can't really common factor anything out of the 15x plus 117. 15x doesn't go into 117. So I can't really common factor anything there. The denominator stays the same. I can just state my restrictions. X cannot equal -5. Oops. -5, -8, or 6, +6. So those are my restrictions for this simplified expression. Two more examples, C and D. So for C, again, we have one fraction or one rational expression where the denominator is simplified, it's factored. I need to do the same to the next one, the x squared plus 6x plus 8. I need to do that first. It's simple trinomial, so two numbers that multiply to 8 but add to 6. These two numbers would be 2 and 4. So that means that I can rewrite this as x minus 2 over x plus 2 plus x plus 10 times x plus 2, x plus 4. The lowest common denominator in this case, I see that they both share a factor of x plus 2. The only thing missing or the only thing different is x plus 4. So the lowest common denominator is going to be x plus 2 times x plus 4. That means I only have to multiply the first fraction by anything, in this case x plus 4. So this becomes x plus 4 times x minus 2 divided by x plus 4 times x plus 2 plus x plus 10 divided by x plus 2, x plus 4. Now that the denominators are the same, I'm going to simplify or expand the numerators so that it makes it easier for me to add. In this case, I'm going to rewrite it. I'm going to make it a little bit simpler, less writing. I know the denominator is going to be x plus 4 times x plus 2. When I FOIL the top, x times x is x squared, plus 4x minus 2x is plus 2x, and then minus 8, and then it's going to be plus x plus 10. I can go through and simplify the top. X squared is going to stay the same. 2x plus x is plus 3x, and minus 8 plus 10 is plus 2. So x squared plus 3x plus 2 divided by x plus 4 times x plus 2. Should have been stating my restrictions. Again, looking back, nothing has really changed in terms of my restrictions. So even when I go back, x cannot equal -4 and -2. So that hasn't changed throughout, so we're okay there. There is one step that I can do further. I can factor the top now. So this is an example where we can factor the top. Oops. if I factor the top, I get, looking again for two numbers, product and sum. So two numbers that multiply to 2 but add to 3. This would be 2 and 1. Just make this a little bit smaller. So now I would have x plus 2 times x plus 1 divided by x plus 4 times x plus 2. I can cancel some things out or simplify. I can cancel out the x plus 2 on the top and on the bottom. So this becomes x plus 1 over x plus 4 with the restrictions of x cannot equal -4 or -2. So this was an example where we could factor the numerator, which is a possibility. So we could factor the numerator in this case, so we do have the one final step of simplifying. We've been looking for restrictions as we go through, but after we kind of find the common denominator, chances are there really isn't much that changes or comes up as different, so to speak. And we have our simplified expression. D, similar idea. We can see that the first fraction or the first rational expression is already simplified in the sense that there's already a factor in the bottom, or we've simplified the bottom or the denominator. The second fraction we do have to simplify to get a common, or to help us find a common denominator. So again, I am going to factor product and sum. So two numbers that multiply to -4 but add to 3. These two numbers would be +4 and -1. So all I'm going to do is just rewrite as 2x, x minus 1, minus x plus 2 over x minus 1 times x plus 4. So all I've done is factored the denominator. I should recognize that for the lowest common denominator, they share a similar factor of the x minus 1. The only difference is the x plus 4. So I have to multiply the first fraction entirely by x plus 4. So I have 2x times x plus 4 over x plus 4 times x minus 1. And that fraction is subtracting x plus 2 over x minus 1 times x plus 4. I can look for restrictions. X cannot equal, you can see it can't equal a -4 or +1. So I'm going to track that now and just see if it changes as we go through. I can expand and subtract kind of at the same time before I collect like terms. Right, so my numerator would be 2x times x, so 2x squared. 2x times 4 plus 8x minus x plus 2. The denominator stays the same. We don't change the denominator. Subtracting, when we're subtracting polynomials, we subtract everything in the bracket. So it's not just minus x, it's minus x and the plus 2. So we have to subtract 2 as well. So this would give us 2x squared plus 8x minus x, so plus 7x plus 2 divided by x plus 4, x minus 1. I could try to factor the complex trinomial, two numbers that multiply to 4 but add to 7. Doesn't work, so I can't factor the top. I can't simplify it any further. So this is as far as I go. 2x squared plus 7x plus 2 divided by x plus 4 times x minus 1 with the restrictions of x cannot equal, x cannot equal -4 or 1. In the last example, a plus 1 divided by 5 minus 2a and divided by, minus a minus 4 divided by 2a minus 5. Right? So in these ones, or in this example, right, Sometimes the denominator is only off or only differs by a factor of -1, right? So in some cases, we may only have to change it slightly without having to do anything really drastic. And what I mean by that is if I rewrite this a plus 1, so the top is staying the same minus a minus 4, we'll leave it as 2a minus 5. Right, this is actually negative 2a plus 5 if I rewrite it with the variable term in front. So I should see that, oh, these are almost identical. The only difference is the signs in the first one. Right, so if we recognize that, then it makes it a lot easier because that means that all we have to do is multiply the first fraction by -1. This becomes negative a minus 1 over 2a minus 5, which would give me a common denominator. So just by recognizing that, it makes it a little bit easier for our common denominator. Looking for any restrictions. Right now, x cannot equal. So this one's going to be a little bit more challenging. Because we do have to look for, it's a little bit harder because we have to move things across. It's not as simple as just saying, oh, well, a minus 1 equals 0, that type of thing. Move the 5 over, divide by 2, this becomes 5 over 2. If I were to look at the first one and say, well, why didn't I do it for the first one? Like if I'm looking for this portion here, well, if I move the 5 over, it becomes negative, divide by -2, it's the same restriction. So even by changing the signs, it didn't really affect anything in terms of this restriction, or in terms of this example. I can collect like terms, or I can do my subtraction. So negative a minus 1 minus a minus 4. So it's again subtracting everything in the second fraction for the numerator. So negative a minus a is negative 2a. -1 minus -4 is the same thing as saying plus 4, so that becomes positive 3 over 2a minus 5. I can't cancel anything out because I'm adding terms. I'm not multiplying anything here. I have two terms being added on the top, two terms being subtracted on the bottom. I can't cancel anything out. So I've simplified as possible. I can't factor. So I can state my final restrictions of x cannot equal 5 over 2. So that is the simplified expression and the restrictions. So again, that was the last example. In this lesson, again, it's mostly just adding and subtracting fractions, very similar to, or adding and subtracting rational expressions, which is the same steps as adding and subtracting fractions, a little bit more complex because we have to factor or think a little bit harder about what the common denominator is. But the main thing is try to factor first to get a common denominator. You might have to multiply by a binomial like we've been doing in the second examples. And then you're going to expand the numerator, collect like terms, see if you can factor. The denominator shouldn't change. If you can factor, let's see, like example C here, then factor the numerator and then look to cancel out or look to see if you can cancel out anywhere else. Making sure you check for restrictions as you go through. So this is kind of it. We've looked at the multiplying and dividing. So that is kind of all we're going to be doing with rational expressions.